first. What did you learn about the process? So last night, when you put everything together in R6, did you learn anything new or have any observations? Anything? Any new mechanism, or you totally dominated, nothing new came up?
No, and you said we would need to go over like with the multiplicity and how you need to figure out like when you have an odd multiplicity or even multiplicity of the denominator, figuring out that like other like the two, I don't remember what the number was.
The constant?
No.
From the video last night,
Yeah.
building it, that's what we're talking about. I'm not talking about the video from last night.
Oh.
I'm talking about last night, R6 itself. When you graphed R6, did you run across anything new about the process? Anything new about the process? There was nothing was new on that rational function?
How about personally?
What about finding the Y-intercept? Okay, so you ran into nothing new at all. Nothing new at all? Yeah.
It's personally because I just figured out that factoring it first will solve any problems in this process more easily.
Factoring first is the way to go. Anything else? It's great, yeah. Nothing else? You rock this one? Yeah? Okay, that's fine. That's fine. .com was down last night. I do know that. Try it tonight, okay? Did it load for you last night? Oh, so did it load for everybody else? No. See, someone does their homework early. Everybody else, it does not work. Okay, so try it again tonight. See if you can get it to work. So you're supposed to come in with a couple observations or cool things about each of these sites. What's one thing you found out about Quickie? Let's go, Sean first. It has lots of content. You tried Korean, it worked?
Yeah.
What'd you learn, yeah?
I searched for neighbor, which is Korean website.
Yeah?
But it was compared with Google, and there was only two pictures like neighbor and Google, but like after 30 seconds, there was only Google picture.
Yeah, yeah.
So it's very weird.
Got it.
If you put in a very specific thing, like I had a presentation
Yeah.
first day, and I tried to put in what it was on, which was technology.
Yeah.
It didn't have anything.
So it doesn't have everything. What else? Yeah.
You can go to related topics through you can just look at the content.
Uh-huh. So once you search for something, related topics can come up. Nice. What else? One and then two, yeah.
To improve it, like Wikipedia, you can completely rewrite articles.
Yeah.
Like with this, you can just suggest that they like look at a YouTube video
Ah, got it.
or like read Stanford, so it's pretty reliable.
Got it.
You trust it.
Well, it's getting its information from.
It's not.
Well, no. Where's it getting it from?
Wikipedia?
Well, it's pulling text from Wikipedia. So what can you change? You could change the Wikipedia, but you're right. You can't change the you can't change the organization. When the suggest button, it only does like video, audio. You can change the streaming, but to change the actual, yeah, it's also mechanically right. Yeah, what?
Three things.
Yeah.
One is you can enlarge the picture.
You can enlarge. Yep. Excellent.
And second is even you type in some nasty stuff, it still
So nasty
say it in a
stuff?
Yeah, he's got a good point about this. Yeah.
say it in a very calm
Yeah.
voice. It's very funny.
Okay, so basically, you can have it say naughty things. Good job. Anything else? Okay, it's something. Great. Thanks for sharing. Anything else?
And, I believe pronunciation of Chinese words.
Ugly pronunciation of Chinese words. Awesome.
Like my city is Hangzhou. Yeah, pronounce it Hangzhou.
Yeah. Well, yeah. I mean, yeah. It does it phonetic. It uses American phonetics. It doesn't use pinyin. It doesn't. Yeah. It doesn't use pinyin. And so did you notice it's only in English?
Yeah, it should come out with different editions.
Yeah. Well, it's brand new, so I'm sure that's something they're working on. I'm sure they are.
Last year.
Yeah. Oh, is that what it said? Oh, really? They're working on it? Okay. Let's talk about Wolfram. Alpha. Let's see, what do we got here? Let's go this way. Anybody? There, Peg, yeah.
They can tell they can calculate a temperature outside, like current temperature.
Can tell current temps? Nice. Yeah.
They add new areas every week.
Add new areas every week. I like that. Yeah. Pang again. Yeah. Go Pang. Yeah.
Oh, and also I heard something about school and university.
Yeah.
They know everything, like the size of the school and.
Ooh, that's a good one.
Nice. What else? Anything else? You were supposed to discover something. Yeah.
I've got extensive family trees.
Oh, really?
A lot of people.
Oh, cool.
Neat. That's cool. What else? Yeah.
When you try to type the word, like they're down there, not that
Yeah. Oh, there are suggestions here too. Suggested words as you type. Nice. What else? Yeah.
I discovered distance from center of U.S. to center of Japan is 10,000 and.
Can look up weird stuff.
Yours.
What else? Anything else? Did you try to do with Wolfram Alpha what you tried to do with Quickie? Did you? Did anybody try it? What happens? It has a great sense of humor.
Really?
In my other class, one student, she left the computer terminal. One of her friends typed in something really not cool, and the search results were, "We don't have information on that subject." And then in the gray text at the bottom, it said, "What would your mother say?" Which is fantastic.
Nice.
Which is fantastic. Yeah. Yeah. Okay. So tonight, please check out Fooplot. Okay. So continuing on with this segment, web tools of the day, I want to show you two things. One, I want to show you Open Education Disk. Open Education Disk is a compilation of free open source software for educational purposes, stuff that you can download directly and run. It's a Windows compilation, but all of these programs also, almost all of them exist in the Mac operating system. So it allows you to get everything that you pretty much ever could need to do on a computer with
Word?
free and legal. Yeah, OpenOffice works really well. Internet, art and graphics, it works really, really well. So it's basically, if you ever need to pay for some software, find out what the alternative is. And actually, there's a website now that I think of, osalt.com. I think it's osalt.com. It's yeah, it is. Alternate software lookup. So you type in some like Microsoft Office, and then it tells you all the alternatives to Microsoft Office that do the same thing. Or like type in Photoshop, it gives you all the alternatives of Photoshop. It's a great resource. So I'll put that in there too. OSAlt. Yeah, I'm gonna show you another thing here. So what I've done here is I've actually in this I changed the videos document that's in your documents page in the folder. Have people seen this? I added in your documents folder. There's a document here, all the videos that I'm showing, and then also I'm gonna put all the web resources right here. So Open Education and OSAlt. I'll show you that. Now there's one other thing I wanted to show you. Let me see if I can find it here. Hold on a sec. This is a really neat infographic. So it's information. This is a static image. You know that video we saw with the guy animating all the sick and poor, healthy and wealthy. This is an infographic of the state budget of Massachusetts for 2011. The guy did it for the federal government. He was contracted to do it for the state of Massachusetts. This is a very small version of it. It was made at very high detail. You can't really see it because you can't really see it, but it breaks it down. The larger the dot, the more money is there. But the idea is it breaks it down from multi-million-dollar expenditures all the way down to like thousands of dollar units. So you can actually see where money is going. Why is this something that's interesting to have, or what's the point of doing this? Has anybody ever seen a budget document like in the capital, like a state budget? Has anybody ever seen one before? Okay, I'll give you a pretty directed question. Are they short documents?
No.
They're enormous documents, right? So what does this allow people to do?
You just get it.
See where money's going. It gives you a visual representation. You see trends. See where it gives you relative sizes. It's a powerful tool. So I put the link of this up, and it's a pretty neat graphic. I highly recommend taking a look at it.
Yeah, these are more obvious.
Okay, so let's do this at random. Ethan, give me. Let's go next. Let's go with Brown. Jessica. Caroline.
2.
Sophie.
1.
Grace. I'm going to make it -6 just to get a little symmetry here.
I have a Y-Intercept.
In your, yes, so we need to set that in your, we'll say that y equals, let's make it, what should we make it? -2 is our y-intercept. So what you're going to do in your small groups, you're going to graph a possible representation of this. There's many representations of this. These aren't the only, they don't have to be the only zeros. See how close you can make it to this. They can be more zeros, but let's see if you can make this. And then second, you're going to build the equation. So that's what I would like you to do right now. I'm going to make your groups for you. So what's the easy part to this? Easy, I think you can, graphing it's not that hard. Graphing is pretty straightforward. Can someone give me, what's the beginning part of the function that you have? What factor, give me one factor you know has to be in the numerator. Someone give me one. X take away 1. Give me another one.
X plus 6.
And give me one factor that has to be in the denominator.
X take away 4.
And what power does one of these have to be to?
X times 4 has to be
Even or odd?
Even.
And this has to be odd.
oh.
Do we know anything else? Ow. Banged my head last night. It wasn't very good. Bookshelf thing, bent down. Ow. Okay, so here's the thing. So this takes care of the vertical asymptotes right here. This takes care of the 0 here and the 0 there. Correct? Okay. What haven't we taken care of yet? Horizontal asymptote. Where's the horizontal asymptote have to occur? -2. It has to occur at -2? Didn't it say horizontal asymptote? Oh, 2. Was that was a good laugh. Whose was that?
I was just kidding.
Okay. It's a 2. When do you have a horizontal asymptote at 2? Someone explain to me clearly. When does a rational function have a horizontal asymptote at 2?
When the degrees of the denominator and numerator is same.
And so it's
And when
the leading coefficients have to be a ratio of 2, right? So where should I put a 2? Numerator, right there. We just took care of the y equals 2 horizontal asymptote right there. So we know that there's a horizontal asymptote at y equals 2 right there. What's the last thing we need to do, though? And what's the degree of the numerator right now? 2. It's a quadratic. What's the degree of the numerator? Denominator, sorry. When you multiply this out, what is it?
But we don't know yet.
We're not, okay, oh yeah, I haven't put anything in yet. You're absolutely right. Okay, so let's actually put in some values. What's the smallest even? You might have done that, right? What's the problem? What's the degree of the bottom? 3. What's the degree of the top?
2.
What?
2.
2. Which is a slight problem, right? Why is that a problem?
because it doesn't.
They need them. You need them to be what? Equal, and they're not. So you'd think you need to put some sort of x term up here, correct? If you did that, it puts in another 0. And what's the one thing we haven't talked about yet? The y-intercept at what? 0 what? 0, -2. Exactly. Now here's the thing you can play around with. We chose 2 and 1. Why? They're the smallest. Let's just bring them up one. How about let's make this one 4 and that one 1. I like to make it, let's keep it 2 and make that one 3. Does it matter? No, it doesn't violate any rules. What's the degree of the bottom now?
5.
What's the degree of the top? 2. Okay. So what will we have to put here? It would have to be an x cubed plus something.
Well, it creates near 0.
Did I ever say, hold on. I never say, I said, bleh. Are you allowed to create another 0?
Yeah.
I said you could, right when you started. You can create another 0. In this case, do you have to? Kinda do. You kinda do. So here's the thing. Let's go back here. Let's go back to the smaller one. So could this be 2 and this be 1? Sure. And if that's the case, what are you going to be multiplying by? X plus some constant. Right? So, what's the we need to make, when x is 0, what does y equal? Equals what? So 2, so what do you get? -2. -2 times 6 times c all over 16 times 3 is equal to -2. Send it with 6c over 48 is equal to 1. So what does c equal? 8. C equals 8. So what did we end up with? C is 8. Now in this case, we created another 0.
Wait,
We created another 0. Where does that 0 occur?
negative.
At -8. And is that okay? Does everything else still hold? Are the vertical asymptotes the same? Are the intercepts the same? Is the horizontal asymptote the same? Yes. In this case, there's no way to avoid. We have to create another x-intercept because of the multiplicities. Because the multiplicities guarantee that 2 of them had to go down on the left, you're going to have to cross the x-axis somewhere around -8. Yes?
In that video, you said you cannot create new zeros. That's real.
In that video, that's the terms I gave in that lesson. In this lesson, you have to create a new 0.
What? Oh, all right.
All right? Do you understand what I'm saying? There is no way to make that graph without creating another 0. There's no way to do it. Last night, there was a way to do it without creating another 0. Do you understand?
Yeah.
Sometimes you have to, and sometimes you can do it without it. Think about it. The picture you drew looked something like this. I'm going to do a rough sketch. You had a y. It was y equals 2, right? What were the vertical asymptotes? At what? 4 and? And you had intercepts where? 1, 0. What else? -6, 0. 0 what? Like that? Oh, y 0, -2, right there, correct? Like that? Could it cross the horizontal asymptote? Why not? Are there any other intercepts given? And negative what? Negative what? 4? -6? So you might think you could have started over here, and I could have done this. Like that. And this could have gone, I don't know, like this. Now, stop! What was the multiplicity here?
Odd.
Was it odd or even?
It was odd.
It was odd? So they need to go in
Opposite directions.
opposite directions? Did it say x minus 3 is opposite? Is an odd, right? Exactly. So this being down here, is that a problem? Well, if it crosses here, we could add in other zeros, couldn't we? So, for example, could this have done this? Woo! Why not? I never said it couldn't. I never said you couldn't create more zeros. You absolutely can. You absolutely can. So that's one way of looking at it. And what was the multiplicity over here? Even. So this one could have gone like this. So is that one possible graph? Is it one possible graph that meets all of the requirements that I gave you? Are there different ones? Yes. So are there different equations you can come up with? Ambiguity is hard. I understand that. You guys really like the safe comfort of there is one answer. Is there always one answer? No, there isn't. Let's chat about the homework. It might be a little different, so finish it. And then write an original Unit 2 test. It's totally up to you what you cover and how you cover it. You must solve the questions on another sheet of paper. Someone else will be doing your test. This is for tomorrow.
How many questions?
Congratulations.
How many questions?
Okay, I'm going to say this one more time. It's totally up to you what you cover and how you cover it.
Oh, okay.
Got it? Totally up to you. What you think would be a fair test. Understand? Okay, you may pack up.